All right, let's go backwards this time. Suppose I give you a picture first and ask you to find the equation. So find the equation of a quadratic whose graph appears as follows. So it looks like I've got two symmetrical points at 17 and 27 of height 13, and I've got an extra point 30, 60. All right, give it a try. Write down an equation that fits that graph. Okay, here's my answer. So clearly 17 and 27 are two interesting x values. When I put x equals 17, when I put x equals 23, they both give an output of 13, which suggests what the equation should be. I could do what I was doing earlier on and just write down the answer, namely y is, x minus 17 is interesting, x minus 27 is interesting, put in x equals 17, put in x equals 27, I should get 0 plus 13. Beautiful. It looks like the equation is y equals x minus 17, x minus 27 multiplied together plus 13. Except I'm not correct, because it's meant to fit this point as well. If I put in x equals 30, I should get 60 coming out. 30 minus 17 is 13, 30 minus 27 is 3, so 13 times 3 is 39, plus 13 is 52. When I put in x equals 30, I get 52, not 60. So I know I'm not right. Oh dear, what am I missing? What am I missing? Well, the thing is, there's probably some steepness to this. There's probably some steepness factor. Let's call it A. I seem to be using A all the time for my steepness. All right, so there must be some number A which actually makes this work beautifully. Now, 17 and 27 are still interesting. If there's a number in front of here, I'll still get 0 if I put x equals 17 plus 13. And I'll still get 0 if I put x equals 27 plus 13. So that number A doesn't ruin my nice x values, but I can use A to adjust it to figure out how to make that point work as well. In fact, actually, let's do it. If I put in 30, I should get out 60. Let's make that happen. Put in 30, out comes 60. So 60 needs to equal A times 13 times 3 plus 13. This is what we had before, I believe. 13 and 3, well, next is 30. Yep, plus 13. All right, so that tells me 60 is 39A plus 13. Okay, now it's just a little bit of work here. 47 is 39A. A must be 47 39ths. All right, an awkward number, but we can manage it, because that tells me the equation is y is 47 39ths x minus 17, x minus 27 plus 13. There is a quadratic equation that fits that particular curve. Hopefully I haven't gone off the board. Hopefully you can still see that. And, well, maybe we'll put it here too. 47 39ths. Wow. That's it. By the way, this is a number bigger than 1, slightly bigger than 1, so it's kind of a shallow graph, actually. If you draw this properly to scale, you probably see a shallow U-shaped graph if you actually were to do it. But there it is. We've done it. Beautiful. Again, just follow common sense. Using symmetry is your friend. Okay, let's now do a very standard textbook type problem. Let's consider the graph of y equals 2x squared minus 8x plus 6. And let's answer these 6 things about it. So let's find the vertex on the graph. Let's find the line of symmetry of this graph. Let's rewrite the equation in vertex form. Let's sketch the graph. Let's find the x-intercepts of the graph. And let's find the y-intercept of the graph. I'm exhausted already just reading the question. All right, so this is a typical textbook problem that's testing everything. Do you know everything about quadratics? And the answer is we do. Now, my first point is, when you're given a long list of questions, no one says you have to do them in the order they're given to you. Now, you know that I'm a very visual person. I think once we've got a picture speaks 1,000 words and common sense reveals everything else. So I'm actually going to go straight to the picture, part D. Let's sketch the graph. Because once I've got the picture, I bet the rest of it's going to fall into place. All right, so let's sketch the thing first. So that means I need to focus on the x part because I want to try to find interesting x values out of this. So I see 2x squared, I see 8x, I'm thinking like 2x is a common factor. Let's pull out 2x. So let's rewrite this as y equals 2x times x minus 4, is that right? Yes, plus 6. So I'm going to think of my equation this way. Because right away I can see that x equals 0 is interesting. I'll get y equals 6, and I see x equals 4 is interesting, I get y is 6. So let me write that down. X is 0 gives y equals 6. X is 4 gives y equals 6. Beautiful. So let me plot those points. Let me start drawing the graph. I'll do it here. Hopefully there's enough space. So I see right away 0 and 4 both give points at height 6. Grand. In fact, now I can actually start answering interesting things. For example, the common sense tells me the line of symmetry is right there, smack bang in the middle at x equals 2. Actually, I guess we answered part B, find the line of symmetry. My answer is, there it is, found it. Actually, this depends on your curriculum. Maybe your curriculum just wants you to point to the actual line, maybe draw the line of symmetry, or maybe it wants the equation of the line of symmetry. So if I want the equation here, I want to know what's true about all the points on this vertical line. Well, these are all the points with x coordinate equals 2, and the y coordinate could be anything. So an equation that describes all the points here are all the points that have x coordinate being 2. For example, the point 2, 5 makes that a true equation in mathematics, a true statement in number sentence in mathematics. X equals 2, 17 makes that true. X equals 2, point 2, negative 94 makes this true. So that's the line of symmetry. I guess I've answered part B. Fabulous, fabulous. All right, but I'm sketching the graph. I'm still doing part D. Where's the vertex? Let's put in x equals 2 to find if the vertex is down here, up here, somewhere. So put in x equals 2, y is 4 times negative 2, that's negative 8 plus 6, it's negative 2, it's down below. So at negative 2, the graph is dipping down to that point there. In which case, I now know my graph. It must be a symmetrical U-shaped graph dipping down like that. Beautiful. There is my fabulous sketch of my graph. I've now answered parts B and D. I'm 1/3 of the way there. Actually, I think I've got more to say right now from the graph, because look, find its vertex. There it is. In fact, they probably want me to write the coordinates. It's x is 2, y is negative 2. So the vertex is 2, negative 2. Done. Part A done. Halfway there. Anything else that's kind of obvious? The y-intercept. This graph is crossing at y equals 6. The y-intercept is the point 0, 6. That's done. Fabulous. So now we've got parts C and E to do. Actually, part C, I put in there a strange term. Rewrite the equation in vertex form. Now, I've not used that word before, and this could happen to you. You could be taking a test or an exam or something, and the examiner is going to use some term, some phrase you've never seen before. My advice is, don't panic, because I bet you can just rely on your fabulous confidence and wits to figure out what it must mean. Just use common sense. So, I don't know what quite vertex forms mean, but common sense says, all right, please rewrite the equation. So I've got to rewrite this some way in vertex form. Now I rewrote it this way, okay, but maybe that's not vertex form, because vertex form, it wants something very clear about the vertex. Now I've got to be able to see that x equals 2 and y equals negative 2 is the vertex. Oh, that makes me think of last lecture actually, because this is basically the y equals x squared graph shifted so that 2 is behaving like 0 and it's shifted downwards by 2. So I do know I could write this equation as y equals make 2 behave like 0 squared and shift down by 2. Yes, yes, I bet that's what vertex forms mean, because there's the actual vertex. I'm kind of seeing it. X equals 2 is behaving like 0 and it's down by 2. Trouble is steepness. I'm probably missing a steepness factor. But look, I could deduce what the steepness factor is going to be, because it's 2x squareds and some stuff. So if I expand this, I'll need 2x squared to come out. Right now I've just got x squared, so I bet I have a 2 in front. Voila, voila. There it is. I bet that's vertex form. Common sense tells me this is the answer to part C. That is rewriting the equation so the vertex is very obvious from the equation. And by the way, you might have noticed that the number in front of the x squareds, no matter how I rewrite the equation, always turns out to be the steepness. So I've been doing that earlier in the last few examples. I haven't actually mentioned that loud, but it turns out that number A is always going to be the factor in front of x squared. So if I rewrite the equation different ways, I need that factor A always to be there somewhere. That number A is the steepness every single time. 2x squared is steepness 2. Beautiful. All right, okay. I'm almost there. So what I've got now? A done, B done, C done, D done, F done. Find the x-intercepts. X-intercepts, that means where it crosses the x-axis. So there and there, what are those points on the x-axis? Now, given this is an exam question, I'm guessing they're probably very nice numbers, namely what, 1 and 3 would be my guess? Well, they probably are, but you know what, we have to share our work. So let's see if they really are 1 and 3, because they could be sneaking, maybe it's like 0.8 and I don't know, 3.2 or something. All right, well let's do it, we have to do it. So can I erase some work? My board is getting very tight, but I'm going to clean all this off. Is that okay? I'll just leave the original equation and give myself some space to write. All right, so x-intercepts, how am I going to work them out? Common sense, what I'm going to do. Well, these are values that have y equals 0. So actually there have to be points x that make y equals 0. So these are the points that solve the equation 0 equals 2x squared minus 8x plus 6. So actually, I'm going to solve a quadratic equation. I'm back to doing the algebra of quadratics. Now, we have lots of choices right now. Lots of choices. We know many different ways to do this. You could do the quadratic formula right now. You could do the box method right now. I could multiply this by 2 to make this 4x squared as nice. Then I have a nice even number in the middle, and that's grand. Or actually, since everything's even, I might divide through by 2 right now and think of x squared minus 4x plus 3 equals 0. And then I could try doing quadratic equation on that, or I could try doing the quadrus method on that. Or if I want to be unsymmetrical, I could try rewriting this as a rectangle, an unsymmetrical rectangle of area 0, and try a factoring technique. That will be grand. So that's what, 3 different ways you could do it right now. But actually, I'm going to do it a different way. I'm going to do it this way. I'm going to do that. Oh, no, not that way. I erased it. That vertex form. What is it I wrote? We had the vertex form was y equals 2 times x minus 2 squared minus 2. I'm going to try a fourth way. I'm going to use the vertex form to solve the x-intercepts. I want this equation. 0 equals 2 times x minus 2 squared minus 2. Let me add 2 to both sides. So 2x minus 2 squared must be 2. Okay, 2 of those. Let's divide everything by 2. X minus 2 squared better be 1. So I'm actually doing the quadrus method right now because that vertex form actually kind of was the quadrus method. Something squared is 1. So my something better be 1 or the negative version. Negative 1. Add 2 to everything. X better be 3 or negative 1 plus 2 is 1. X is 3 or 1. So actually, yes, that must be 1, that must be 3. The x-intercepts part E is x equals 1 or x equals 3. The x-intercepts are actually, I should say, 1, 0 and 3, 0. They're the x-intercepts. Wow, how's that for speed? So I end up using the vertex form. Actually, I think that one would be hard to use. You could use that directly. Lots of choices. There are lots of choices for actually working out the algebra for that final part of the x-intercepts. All right, but my point is, you are in control of your own fabulous thinking. Just use your common sense, make your own choices, and it'll work out. It'll be grand. Good for you. So in fact, let me give you one to practice on right now. Actually, let's just keep doing practice problems. For example, let's try this one. Find the value k so that y equals x plus c times x minus c plus k, I guess c is just some other number, has the smallest possible y value of negative 2. That is, if I sketch this graph of all the possible y values that come out, I want the smallest y value I could see being negative 2. What value of k should I choose to make that happen? Give it a try.